This is a demonstration video of the Agile Streets Phase 1 testing. The test environment comprises hardware deployed across 2 test labs at PNDC and Itron, and software platform functionality hosted by 3 consortium partners, Samsung, Octopus and Connected Kerb. Every effort was made to implement an end-to-end test environment that closely resembled that of a real-world deployment. An underlying feature of the Agile Streets platform is Octopus's Agile tariff, updated daily and published via an API. In this screen, a log from the Samsung platform shows the daily retrieval of the Agile tariff rate in pence per kilowatt hour. The Agile rate for one of the test days is trended here, showing the energy price variability across each period of the day. In the Agile Streets platform, a charging session is initiated by a user via the Connected Kerb app. This functionality permits the user to enter the energy volume they desire and the time at which they plan to return. The user is also presented an option if they want to participate in optimized charging or charge as fast as possible. After the user enters their preferences, this information is sent from the app to the Connected Kerb backend and to the Samsung optimization platform. Connected Kerb will authenticate the charging session on the charge point and request the user to connect the vehicle to the charging socket. The test setup at PNDC comprises an LV network with 4 EV charge points connected to a single phase. The hardware in this photo shows the black EV charge point socket in the middle with the Connected Kerb power pack and control box, normally installed under the ground, located in the bottom right. After the charging session is initialized, the Connected Kerb hardware will flash blue LEDs. These LEDs will transition to solid green once a connection is established with the vehicle and a charging session will begin. Feedback of a successful charge session will be presented to the user in the usual way, usually a beep or flash of the vehicle lights, and in the Connected Kerb app. Initially, the EV will be charged at a low power rate of 1.4 kilowatts to permit this feedback and to allow the user to leave in confidence that a charging session has begun. The user app will provide ongoing updates of live information, including the current power consumption of the vehicle, the accumulated energy delivered, session duration, and the corresponding cost. In parallel to the initialization steps outlined previously, the Samsung optimization platform will calculate the optimal charging profile that meets the user's energy requirements and charge by time, while minimizing the energy costs based upon that day's Agile tariff rate received from Octopus. In this screen, a log from the Samsung platform shows a request received from the Connected Kerb app, which includes the user input requirements and identifying information about the charge point hardware. The receipt of this request triggers the computation of an optimal charging schedule, providing the charging power, high or low, for each half-hour period of the session. This information is then sent to Octopus via an API integration that also includes the hardware identifiers for the EV charge point and the associated ESME and HCalcs devices that will transfer the load control message. A visualization of the charging power rate for each half-hourly period calculated by Samsung is shown in this screen. The EV charging rate, trended in orange, is laid on top of the Agile tariff in blue. This shows a period of low power consumption when energy costs are at their highest. When Octopus receives the optimized charging schedule for a new session, the information is used to construct a load control message to be issued to the relevant charge point. Octopus issue this load control message via an SR 14.1 message sent to the TMA system.
This is the Itron test lab, where we have devices connected to the UIT test environment or to Itron's own environment, where we can send messages to. Note the cellular modem that allows messages from the HCalcs to be sent directly to the PNDC environment. Using our test tools, we can take the same SR 6.14.1 message that Octopus sent to the TMA system and transmit this to the devices. The label message description can be displayed by the meter and is made available to the HCalcs via the Zigbee HAN network. The HCalcs checks every 10 seconds for a new message, Then each time it has a new message, it transmits this over the serial RS-232 port. This labeled message has encoded within it the calendar needed for the EV charger, which is updated every 10 seconds by the HCalcs.
The updated HCalcs label containing the charge point schedule is then serialized by the HCalcs device and issued via an RS-232 output to the local charge points. If a charge point receives a message from the HCalcs that is addressed and formatted correctly, it will apply this schedule to the connected vehicle, varying the maximum power permitted for each half-hourly period between high and low power. This video displays what a user would see when a transition from low power to high power occurs. When a user wishes to end a charging session, they can do so via the Connected Kerb app, as shown on the current screen. The user can navigate to the map and select their active charging session. From here, the End Charging Session button will stop charging and provide the user with a summary of energy and cost information.